Hi, this is Gigi from Kauai Community College. In this problem, we will go over the application of the quotient rule in taking a derivative. Okay, so how do we know f of x is a quotient? There is a division problem here. So here is a quotient, and the numerator involves a sum. Okay, so what do we know about these derivative rules so far? We know that the derivative of a sum is just going to be the sum of the derivative. And we also know that the derivative of a quotient is not the quotient of the derivative. Rather, it has a complicated expression for that. The denominator is g squared. And the numerator would be the derivative of the first times the second minus the derivative of the second times the first. And it's very similar to the product rule on the numerator, except for that it's subtraction instead of addition. Okay, what else do we need to know in order to do these problems? We need to know that the derivative of sine of x, okay, is cosine of x. And the derivative of cosine of x is negative sine of x. And then we need to know also the derivative of e to the x with respect to x is itself e to the x. So those are the things that we must know in order to do this problem. Okay, so go ahead and apply the quotient rule. So then the derivative of f of x is, I know from the beginning that the bottom is going to be the denominator square. So e to the x squared. Okay, so applying the chain rule here. I mean, not chain rule, the quotient rule here. Okay, and then the numerator have the derivative of the first, which would be sine x plus cosine x, and the derivative of a sum is the sum of the derivative, so that will just be cosine of x minus sine of x multiplied by the denominator, which would be e to the x minus the derivative of the denominator, which is e to the x, multiplied by the numerator, which would be sine x plus cosine x. Okay, so you can see how I write parentheses here and I don't write parentheses here. Really, it's you should understand that x is the argument, even if I don't write that parentheses. Mathematically, better this way. But it's more pleasant to the eyes when it's not too busy. Okay, so be careful of that. If you know what you're doing, go ahead and not write the parentheses, and I'm okay with that. However, if it was sine of 2x, then we better put the parentheses there. Okay, let's go ahead and simplify. We can see that both of these have e to the x there, so we're going to go ahead on the numerator, factor out e to the x. Okay, so e to the x, we're going to factor that part out. Okay, what do we have left with? We have left with cosine of x minus sine of x minus sine of x minus cosine of x. That's on the numerator, and on the denominator I have e to the x squared. Okay, now I'm going to go ahead and take the opportunity to explain. Sometimes you will see not e to the x together squared, but you will see people will write e to the 2x, just because when you have an exponent raised in exponent, we multiply the exponents, right? So it's 2x. but really it's just e to the x and then square. In this case, it looks better to see e to the x and then square, because we know on the numerator there is a factor of e to the x, so one of them will get divided out and we have left with just e to the x, right? And then we will also see what's going on inside there. When we simplify the inside, we will say, oh, look, cosine of x minus cosine of x, that is gone. And on the numerator, then I will just have the derivative of f of x is, I have 1 e to the x on the denominator. On the numerator, I have negative 2 sine of x. And that is